Good morning to all. Uh, in today's session, we discuss about the last part of Unit 2, that is worm and wormwheel. In Unit 2, there are four different topics. That is, first one is the helical gear, second one is the bevel gear, third one is the spiral gear, and fourth one is the worm and wormwheel. In today's session, we discuss about worm and wormwheel. The content of today's lecture is the terminology used in a worm and wormwheel, what, what is the velocity ratio and center distance between worm gears and efficiency of the worm gears. Okay, these are the content of today's topic. What is worm and wormwheel? This type of the gear or this type of the mechanism is called as the worm and wormwheel. This rod is called as the worm and this gear is called as the wormwheel. Okay. If we see, this rod is look like a screw and this wormwheel is look like our gear part. So what are the terminology or what is the efficiency or the velocity ratio of this we will discuss, and what are the advantages disadvantages of this gear. When worm and wormwheel is used, when the shaft are non-intersecting but their axes are normally right angle to each other. If we see here, uh, this is the axis of the worm and this is the axis of the gear. Then these two axes are never meet with each other because there is some distance between these two gears. Therefore, this type of the gear are used when axes of the shaft are not intersecting with each other, but their axes are perpendicular to each other. If we see, these axes are perpendicular to each other. Means what? When worm and wormwheel is used, when the axis of the gears are not intersecting to each other but perpendicular to each other, this type of the when this type of the situation is occur, then worm and wormwheel are used. The second, the worm and wormwheel gear are special case of the spiral gear in which shaft angle is 90°. Means it is a one case of the spiral gear, that is we seen what is a spiral gear, what are the terminology used in a spiral gear. It is the one type of the spiral gear where the shaft angle is 90°. Okay. This worm drive, if we see here in this diagram, the hands of these gears are same. Means if the worm is left-handed, then worm wheel or worm gear is also left-handed. Or if worm is right-handed, then worm wheel also right-handed. Means the hands of the gear are same here, and this type of the gear are used for a very large reduction ratio. When we require to reduce the speed, then such type of the gear is used. The most important property of the worm and wormwheel is it is non-reversible. Means what is mean by non-reversible? Means worm is always driver and wormwheel always driven. There is no vice versa. Means the power input is always given to the worm and output is always obtained and as the worm will. If this will not happen when worm will is we given input to the worm wheel and worm will rotate. This type of the situation will not happen in worm and worm wheel. Due to this non-reversible property of worm and worm wheel, this mechanism is used in the steering mechanism. Okay, if we see our steering mechanism of the automobile in which the worm and worm wheel are used. Okay. Then what are the advantages of the worm and worm wheel? These are compact in nature. These worm and worm wheel are compact in nature if we compare it with the spiral gear, or if we compare it with the helical or a bevel gear. These are the compact in nature. Another advantage of this worm and worm wheel is it is used for a high reduction ratio. If we want to reduce the speed, then such type of reduction ratio is high in a worm and worm wheel. It has a self-locking and non-reversible properties. Self-locking means if we give the input to the worm wheel, then worm will not rotate. This is called as self-locking. And non-reversible means when input is given to the worm will not rotate. This is the advantages of the worm and worm wheel. And operation of the worm and worm wheel is smooth and quiet. Operation of the worm and worm wheel is smoothly and quiet. Then what are the disadvantages of the worm and worm wheel? The first disadvantage of the worm and worm wheel is efficiency is low. The efficiency of the worm wheel is low due to the operation. During the operation, the heat is generated in worm and worm wheel, so that effective cooling is necessary for a worm and worm wheel mechanism. This is another disadvantages of the worm wheel. The manufacturing of the worm wheel is difficult. If we see this type of the manufacturing, if we see in this image, the manufacturing of the worm and worm wheel is difficult, and due to difficulty in manufacturing, the cost of worm and worm wheel is more, means it is more expensive than other type of the gear. Then what are the applications of the worm and worm wheel? These are used in steering mechanism of the automobile. It is used in a crane, dam gates, the gates which is used at the dam to control the uh, or to flow the excess of the water from the dam. Such type of the mechanism where the worm wheel is used. In lift also worm and worm wheel are used. Okay, these are some applications of the worm and worm wheel. It is also used in a musical instrument like a guitar for locking of the string. To lock the string, worm and worm wheel type of mechanism is used in a gear. Okay, these are the some applications of the worm and worm wheel. Okay, if you have any questions regarding the worm and worm wheel, its advantages, disadvantages, properties of the worm and worm wheel, you can ask here. Okay.
Sir, what is material?
We will move further. Then terminology of the worm and worm wheel. See here, some terminology are used. This is the worm. This is the rod type of the mechanism or a screw type mechanism. And here the terminology used is, first is pitch circle diameter. The diameter, pitch circle diameter D2. D2 is the pitch circle diameter of the worm. Axial pitch. What is mean by axial pitch? The distance between, I will take this first screw and this is the second teeth, then if we take the distance from one point and same corresponding point on a next tooth, then it is called as the axial pitch. The axial pitch is the distance between a two corresponding teeth, distance between two corresponding points on a teeth. This is the first teeth, this is the second teeth, and then if we take the distance on the same point on the teeth, then it is called as the axial pitch. It is denoted by the PA. Then what is a lead? Lead is the distance when if we rotate these this worm, then distance traveled by this worm in axial direction. If we give the one revolution to this worm, then distance traveled by this worm in axial direction, means distance travel in this direction, then this is called as the lead. For a single start, the lead is equal to axial pitch. If there are a two start screw or two start worm, then lead is equal to 2 into axial pitch. If there is a three start worm, then lead is equal to 3 into axial pitch. This is the relation between pitch and axial pitch, and the lead. Okay. Then next terminology is lead angle. Lead angle is denoted by the delta, and it is the angle. If we see here, this is the perpendicular line. This is the perpendicular line to the axis of the worm, and then this angle made by the teeth on the worm is called as the lead angle. Lead angle is delta, and it is the angle made by the helix of the worm with plane perpendicular to the axis of the worm. Then next terminology is helix angle or spiral angle. There are two names which are the same in case of worm and wormwheel. Helix angle or spiral angle. What is that? We will see here. If this is the axis of the worm, if this is axis of the worm and angle made by the teeth with the axis of the rotation. The teeth which makes an angle with the axis of rotation. If we see here, this is the angle made by the teeth, and this is denoted by the alpha 2. Alpha 2 is the angle made by the teeth with the axis of rotation, and 2 is used for a worm. Therefore, alpha 2 is the spiral angle for a worm, and alpha 1 is the spiral angle for a gear. And if we see, both the axes of the shaft are perpendicular each other. Therefore, if alpha 2 is the helix angle for a worm, then and alpha 1 is the helix angle for a worm wheel, then summation of alpha 1 plus alpha 2, alpha 1 plus alpha 2 is equal to 90 degree. The summation alpha 1 plus alpha 2 is equal to 90 because alpha 1 is the helix angle or spiral angle for a worm wheel, and alpha 2 is the spiral angle for a worm, and summation of these two is 90 degree. Okay. Then we'll see what is the terminology used here. The first one is axial pitch, distance measured along the axis from a point on a one tooth to the corresponding point on the adjacent tooth. Axial pitch is denoted by the PA, and axial pitch is equal to circular pitch for the worm gear. Axial pitch PA, it is denoted by the PA. Then lead. What is lead? The distance moved by the point on a helical profile when worm is rotated through the one revolution. When worm is rotated in a one revolution, then distance traveled by the point in axial direction when worm is completed its one rotation is called as the lead, and lead is equal to N into L. Lead is denoted by the L, and it is equal to N into PA, where N is equal to number of start and PA is equal to axial pitch. Okay. Then lead angle. we see what is the lead angle here. Delta is denote the lead angle, and the angle between tangent to the helix to the line normal to the axis. Tangent to the helix means if we take the tangent to this teeth and line perpendicular to the axis, this angle is called as a delta, and delta is equal to 90 minus alpha 2. If we see here, uh, sorry, delta plus alpha 2 is equal to 90 degree. Okay, delta plus alpha 2 is equal to 90 degree. So here delta is equal to pi by 2 means 90 minus alpha 2, that is 90 minus alpha 2, where alpha 2 is the spiral angle for a worm and alpha 1 is the spiral angle for a worm wheel. Okay, then if we see in this image, tan of delta is equal to lead by pi by 2, lead of the worm, and if d2 is the piece circle diameter of the one. We know that alpha 1 plus alpha 2 is equal to 90 degree. Therefore alpha 1, if we see here, alpha 1 plus alpha 2 is equal to 90 degree, then alpha 1 is equal to 90 minus alpha 2, and therefore if we see alpha 1 is equal to 90 minus alpha 2, similarly delta is equal to also 90 minus alpha 2, therefore alpha 1 plus delta, alpha 1 is equal to delta, where alpha 1 is the spiral angle for a worm gear. The spiral angle for a worm gear, alpha 1 is equal to lead angle of the worm. This is the relation between a spiral angle for a worm gear and lead angle. Okay. Then next, velocity ratio and center distance between a gears. Velocity ratio means speed of the worm to the ratio of the speed of the worm to the speed of the worm wheel. See here, let theta 2 is the angle turned by the worm in a one revolution. Means theta 2 is the angle of the worm and theta 1 is the angle turned by the worm wheel. When worm is rotate through 180 degree, sorry, worm is rotate through one revolution. Means what? When this worm is complete one revolution, that is the angle turned by the worm is 2 pi. When worm is complete one revolution means angle turned by the worm is 2 pi. Similarly, when this worm, if consider worm is driver, then how much angle turned by the this worm wheel? Okay, see here. Suppose this is my worm wheel and this is my worm. If this worm is complete one revolution, this is a, okay. When this worm complete one revolution, then when worm complete one revolution, then this is the angle theta 1. Theta 1 is the angle through which worm wheel will rotate. This is the angle through which worm wheel will rotate, and we have to find out this. See here, theta 2 is the angle turned by the worm in one revolution. Theta 1 is the angle worm turned by the worm gear in one revolution. And what is this angle? Suppose this is a circle of the worm gear and this is the angle theta 1, which is through which the worm gear is rotated, then this theta is equal to we have to calculate this distance. This distance is equal to lead, and therefore lead is equal to r into theta. If we this is for a worm gear, therefore radius of the worm gear and theta 1 is the angle. Therefore lead is equal to r into theta 1. Means what? When this worm is complete one revolution, then the distance turned by the worm wheel is equal to lead. Therefore, theta 1 is equal to L upon R1. We write R1 in terms of radius. Therefore, L upon D1 by 2. We transfer this D1 on upper side. Therefore, theta 1 is equal to 2 into L divided by D1. Okay. And the velocity ratio is the ratio of angle turned by the worm gear in one revolution of worm. When worm is rotated through one revolution, then what is the angle turned by this worm gear? Therefore, velocity ratio is equal to theta 1 upon theta 2. We have theta 1 is equal to L 2L divided by D1, and theta 2 is equal to 2 pi. Therefore, velocity ratio is equal to L upon pi into D1. L upon pi into D1, where L is equal to lead and D1 is the diameter of the worm gear. So we write L is equal to N into PA, where N is equal to number of start and PA is equal to axial pitch. Therefore, velocity ratio is equal to N into PA divided by pi into D1. This is the formula which is used for calculating the velocity ratio. Okay. Have you any doubt here? If you have any doubt, you can ask me here. Okay, we will move further. The center distance between the worm gears. And what is the center distance between worm and worm wheel? See here. L is equal to center distance between worm gears alpha 1. Alpha 1 is the spiral angle for a worm gear. Alpha 2 is the spiral angle for the worm. These screw type structure is called as the worm, and this is called as the worm gear. This circular part is called the worm gear. Then T1 is the number of teeth on a worm gear. T2 is equal to number of teeth on a worm. Remember, in some book, instead of the T1, Z1 or Z2 are also used. It is, but meaning is same. That is number of teeth. Then MT1. MT1 is the transverse module for a worm gear. MT2 is equal to MT2 is the transverse module for a worm, and MN is equal to normal module for a both module for worm and worm gear. NM is the common term which is same for worm and worm gear, which is denoted by the M suffix N. R1 is the radius, pitch circle radius of the worm gear. R1 is the pitch circle radius of the worm gear, and R2 is the pitch circle radius for a worm. R2 is the pitch circle radius for a worm. Now we have to calculate the center distance. Center distance means summation of this radius plus summation of this radius. See here, we know that we can write radius in terms of module and number of teeth. Where R is the radius is equal to M into T into capital T. Means transverse module into number of teeth divided by 2 is equal to radius of the gear. Then for a pitch circle radius of the worm gear, if we see here, pitch circle radius of worm gear is equal to R1 is equal to MT1 into T1 divided by 2, and pitch circle radius for a worm is equal to, it is denoted by the R2, and it is equal to MT2 into T2 by 2. Okay. This is the radius. Then if we take the summation of this both the radius, then we will get the center distance. Okay. Then center distance is equal to L is equal to R1 plus R2. We write R1 in terms of MT1 into T1 divided by 2 plus MT2 into T2 divided by 2. We will then we will write what is Mn in while we know that if we want to write a transverse module in terms of normal module, then transverse module is equal to normal module divided by cos of this helix angle. Therefore, we can write here MT1 is equal to Mn divided by cos of alpha 1. MT1 means if we want to write a transverse module in terms of normal module, then transverse module is equal to normal module divided by cos of this helix angle. Therefore, MT1 is equal to Mn into cos of alpha 1, and MT2 is equal to Mn into cos of alpha 2. Okay. Then we will take Mn by 2 common. Therefore, center distance is equal to Mn by 2 into T1 upon cos of alpha 1 plus T2 into cos of alpha 2. Okay. Then if we take alpha 2 as a common, we write this Mn is equal to MT2 into cos of alpha 2. Normal module is equal to MT2 into cos of alpha 2. This 2 divided by 2 is into T1 upon cos of alpha 1 plus T2 into cos of alpha 2. Then we multiply this in bracket term by cos of alpha 2. Then we will get MT2 by 2 into T1 into cos of alpha 2 divided by cos of alpha 1 plus T2 into cos of alpha 2 divided by cos of alpha 2. This cos of alpha 2 will get cancelled, and we will get next equation. Then we will get this next equation is equal to T1 into here we have a term that is cos of alpha 2, but we can write as, we know that alpha 1 plus alpha 2 is equal to 90 degree. We know that alpha 1 plus alpha 2 is 9. See here, alpha 1 plus alpha 2 is equal to 90 degree. Therefore, alpha 2 is equal to 90 minus alpha 1. Alpha 2 equal to 90 minus alpha 1. Okay. And therefore, center distance is equal to MT2 divided by 2 into T1 into cos of 90 minus alpha 1 is equal to sine of alpha 1. Therefore, T1 into sine of alpha 1 divided by cos of alpha 1 plus T2. Therefore, center distance is equal to MT2, transverse module of the gear 2, that is transverse module of the worm gear divided by 2 into T1 into tan of alpha 1 plus T2, where alpha 1 is a spiral angle for a worm. Okay. And we know that alpha 1 is equal to alpha 1 is equal to delta. Alpha 1 is equal to delta, therefore center distance is equal to mt2 divided by 2 into t1 into tan of delta plus t2, where delta is called as the helix angle. T1 is the number of teeth on a worm, T2 is the number of teeth, sorry, T1 is the number of teeth and on a worm wheel, and T2 is the number of teeth on a T2 is the number of teeth on a worm, and this is the equation where this is the equation to calculate the center distance between a worm and worm wheel. Okay, this is a formula to calculate the center distance between a worm and worm. Okay. Now, the next topic is efficiency of the worm and worm gear. Efficiency of the worm and there is one question asked in exam, that is derive the expression for efficiency of the worm gear when worm is a driver. Or one question is also asked, consider the worm and worm wheel as a special case of spiral gear and derive the expression for efficiency. Means this equation will ask for to calculate the efficiency of worm and worm wheel. This will ask for examination. See here, the worm and worm gear is a special case of the spiral gear. It is a special case of the spiral gear with shaft angle 90 degree. Therefore, efficiency is same for a spiral gear. If we see the formula of spiral gear and the formula for efficiency of the worm and worm wheel is same. So efficiency of the spiral gear is given that efficiency is equal to cos of alpha 1 into cos of alpha 2 plus phi divided by cos of alpha 2 into cos of alpha 1 minus phi, where alpha 1 is the helix angle for gear 1 and alpha 2 is the alpha 1 is the spiral angle for a gear 1 and alpha 2 is the spiral angle for a gear 2, and phi is the friction angle. Phi is the friction angle. See here, efficiency is worm gear is drive. See, in case of worm and worm gear, the worm is always driver, but here this formula is for what? When a worm gear is a driver. Okay, we will see further this both the formula when worm is driver or worm gear is driver, the efficiency will be the same. So we will move further. We know that alpha 1 is equal to delta. Alpha 1 is the spiral angle for a worm and which is equal to delta, that is helix angle. Sorry, it's called as the, so it is a lead angle, sorry, delta is a lead angle and which is equal to spiral angle of the worm, and alpha 2 is equal to, alpha 2 is the spiral angle for a worm gear and which is equal to 90 minus alpha 1. So we will put here alpha 1 is equal to delta and alpha 2 is equal to 90 minus alpha 1. Therefore, efficiency is equal to cos of delta into cos of, we put here alpha 2 is equal to 90 minus alpha 1. Therefore, cos of 90 minus alpha 1 plus phi is the friction angle, and cos of alpha 2 is equal to 90 minus alpha 1 into cos of delta minus phi. Okay, then these if we take their this minus sign common, then cos of delta into cos of 90 minus delta minus phi into cos of 90 minus delta into cos of alpha minus phi is equal to alpha is equal to delta, that is delta minus phi. And if we solve this, we will get efficiency is equal to tan of delta minus phi upon delta, where delta is the lead angle and phi is the friction angle. Okay, then if we move further, this is the maximum efficiency in a case of spiral gear. If we see the maximum efficiency for maximum efficiency of the spiral gear, then maximum efficiency of the spiral gear is equal to 1 minus sine of phi divided by 1 plus sine of phi, where phi is the friction angle. Okay, then what is the efficiency of the worm, maximum efficiency of the worm and worm gear? See here, when worm is driver and worm gear is driven. If worm is a driver and worm gear is driven, then efficiency is equal to cos of alpha 2 into cos of alpha 1 plus phi, cos of alpha 1 into cos of alpha 2 minus phi. We will put alpha 1 is equal to delta and alpha 2 is equal to 90 minus delta. Okay, and if we solve it, we will get efficiency when worm is driver is equal to tan of delta divided by tan of delta plus phi. This is a formula for efficiency of worm and worm wheel when worm is driver. Okay, when worm is driver. Now maximum efficiency for a worm and worm wheel, the maximum efficiency is not affected when worm is driver. If we see this formula for maximum efficiency of the worm and worm wheel, and if we see same formula when maximum efficiency of the, when we want to maximum efficiency of the spiral gear, means what? We will get a maximum efficiency when worm is driver, and this formula will equal to 1 minus sine of phi divided by 1 plus sine of phi. This is the equation. I will share the attendance link. Mark your attendance. Next topic we will cover in the next lecture.